Welcome to section 8.3, Measures of Dispersion. So in my class, the first thing I did when we talked about this is I asked the question, what is the definition of disperse? And the word disperse, which is the root word of dispersion, has lots of different definitions, or it can be written lots of different ways, but the ones I focused on were to disperse means to distribute or spread over a wide area. Can also mean to spread widely or disseminate. So I want you to focus on the word spread. So measures of dispersion are really measures of how spread out our data is. So let's go ahead and dive in. Our objectives for this lesson: can we determine the range for a data set, and can we determine the standard deviation for a data set? The range is what we're going to look at first, but right here we're going to talk about measures of dispersion being describing the spread of data. And the two most common measures of dispersion are going to be range and standard deviation. So we're going to talk about range first, and then we'll talk about standard deviation. The two main measures of spread or measures of dispersion. So the range is just the difference between the highest and the lowest data values in a data set. So it's the total spread of the data. So here's our formula for calculating range. You just take the highest value and you subtract the lowest data value. So for an example, let's say Honolulu has a hottest day of 89 degrees and a coldest day of 61 degrees. That would mean the range in temperatures is 89 minus 61, the hottest minus the coldest, the highest minus the lowest. So we get 28 degrees for our range of temperatures. And if you watch the news or listen to radio or even look on social media, sometimes they might use that word range. It's just the spread. Okay, example 1, computing the range. So let's say, for example, we have this lovely little graph. And remember, we talked about a good graph has a title that explains a little bit about what we're doing. It has labels on the x and the y-axis, the horizontal and the vertical. So we have a good graph here, and we're talking about the age of oldest presidents, and we're supposed to find the range for the 4 oldest presidents. And notice it's the age at inauguration here. And they labeled the tops of the bars for us, so we don't have to worry about how to read those. They're right there for us. So the range is going to be the highest, which is 70, minus the lowest, which is 65. So our range is going to be 5 years. All right. Now we're going to talk about standard deviation. Range is such an easy topic. We're going to just jump right into standard deviation. Now, our data set doesn't match. There's a typo here. We're supposed to be finding the deviations from the mean for the 4 data items. I'm not sure how this got in like this. So we're going to do 69, 68, 65, and 70. We're going to do this for these presidents. Now notice it says find the mean, and again, I apologize. I'm not sure how this data set got messed up, but we're not supposed to have a 64 in here. We're just going to average those 4 numbers right there, the 70, the 69, the 68, the 65. So we add them up, we divide by 4, we get 272 for our numerator. Scratch out that 64, it's not supposed to be there. 272 divided by 4, which is a mean of 68. So the average, or the mean, is 68 years. Okay, 68 years. And remember, if you use your calculator to do this, you need to make sure you put the sum in parentheses if you're going to do it all at the same time to make it do the adding before it does the dividing. Okay, let's look at some more of this. So let's keep going. So the first thing we have to have for the calculating standard deviation is we need to find the mean. Second thing we need to do is we need to find the deviations from the mean for each of the data items that we have. So if the mean age for those 4 oldest presidents is 68 years, we now need to calculate the deviation from the mean, which is just the difference between the data item and the mean. So let's say we wanted to do the deviation from the mean for President Trump. So his deviation from the mean would be 70 minus 68, which would be 2. So, which means that his age exceeds the mean by 2 years. It's 2 years larger than the average, 2 years more than average. Okay? If we looked, for instance, at Buchanan, his would be 65 minus 68. It would be -3, meaning that, oh, look, we're actually going to do his. Well, let's go ahead and do his. I need to move my slide a little bit. So for Buchanan, we're going to do 65, which is his age at inauguration, minus the mean, which would be -3, meaning that Buchanan's inaugural age was 3 years below average. Okay? Next, we're going to go through the steps for computing standard deviation. We haven't done it yet, so we're going to give you the steps. Here they are. So you first of all find the mean for the data items. So you add them up, divide by how many there are. We're going to find the deviation for each data item by doing this subtraction, data item minus the mean. Then we're going to square each of those deviations. We're going to add the squares of those deviations, and then we're going to divide that sum by n minus 1, where n represents the number of data items. And then we're going to take the square root. So it's this long process to find the standard deviation. That's why most of the time we let the calculator do it for us. If you have a good calculator, it will actually do this for you. So you find the mean, you find the deviation for each data item, you square those, you add the squares that you found in step 3, then you divide that sum from step 4 by n minus 1, where n is the number of data items. And finally, your final step, your last step, is to take the square root of what you found in step 5. And that's the standard deviation. So it's a long process. So we're going to go ahead and we're going to do this process on our 4 oldest U.S. presidents. So we're going to find the standard deviation. First thing is we find the mean. Well, we've done that already. It's 68. We're going to find the deviation for each data item. So we've done a couple of those. We didn't do all of them. We just did a couple of them. So we're going to build a table where we find the rest of them. So the deviation from the mean for Trump was 2. Okay. For Reagan, 69 minus 68, which is 1. For Harrison, 68 minus 68, which is 0. And finally, for the last president in our list here, for Buchanan, we calculated that one, it's -3. Okay, now notice, and this is important, that if you've done it correctly, the sum of the deviations should be 0. But now we need to square those numbers. So usually we're not going to worry too much about that. We're going to assume we've got the right calculations. So we're going to square each of those. So 2 squared is 4, 1 squared is 1, 0 squared is 0, and -3 squared is 9. All of these squares should come out to be non-negative numbers. They have to be 0 or positive. And then we're going to sum those. So notice we added them all up. Okay? So we now are to the end of step 4. We've done the sum of the squares. So now we're going to move into step 5, where we're going to divide the sum, in this case, by 4 minus 1, because our n is 4. We had 4 data items. Okay, so we're going to divide by 3. So for ours, what was our sum? Let's look back. Sum of our squares was 14 at the bottom. And then we have to divide by n minus 1, but that's 3. 4 minus 1, which is 3. So we have 14 over 3, which is going to be, actually, you know what? We might just leave it as 14 over 3. I think we will. If you needed it as a decimal, we could do that. Right? I think we'll just leave it as 14 over 3. And then we're going to move into step 6. Okay, so what we're going to do is we're going to do the square root of 14 over 3. So I'm just going to grab my calculator, and I'm going to do the square root of 14 over 3. So I'm going to do the square root button. I'm going to do 14 divided by 3, and I come up with 2.1602, and on it goes. I'll just round it to 2.16. So the standard deviation for the 4 oldest U.S. presidents is 2.18 or 2.16 years. Now, what does that mean? So we say, so what? What does that mean? Well, what that means is that on average, our U.S. presidents are 2.16 years away from the average. So it's how far, tells on average how far our data items are from the mean. On average, how far each data item is from the mean. So it's a measure of how far our data spreads from the average. That's really what it is. Measure of how far the data is spread or dispersed from the mean. And that is the end of our notes.